So there's three cases. We talked about this the other day, that you can use the law of sines given two angles and a side, really in either order, any two angles and any side. You can definitely solve using law of sines. And then there's the one kind of weird case. We call it the ambiguous case, or I call it the bad word information. If you spell it the wrong way, it could be a bad word. But that's the case we have to be careful of. It kind of works, but we have some interesting answers we're going to learn about today. Let's actually just look at a file here for a second. I want you to see why why using sines to solve an oblique triangle causes problems. Because sometimes when we have this triangle like ABD triangle here, um, sometimes you're using sine. Well, you kind of don't know if what's interesting is if you notice this, those two angles are supplementary. So 52.9 and 171, 127.1 are complementary. The sine of both of those angles, they're supplementary. The sines are the same. If you kind of move this and do it somewhere else, those are still supplementary. The sines are the same. So because that's actually the thing that causes a bit of a problem when using law of sines, we kind of never know if you're given an ambiguous case, if that angle is like a 47-degree angle or a 132-degree angle, because it literally gives us the same number with law of sines. So that causes some issues, I would say, in this. What kind of issues? Well, let's look. So say you have a triangle like this. So if you kind of try, so the given information is the angle is 50 degrees, and that actually is, by the way, I drew a 50-degree angle there. The side B is right there, and that is 5 units, and side A is exactly 4 units, so in relation to that. And so we don't really know what angle C is, so angle C could be very big or very small, but actually it's in order to form a triangle, it has to hit that line that's at a 50-degree angle there. So you can see right there, it does in fact form one triangle right there. You formed a triangle. Huh, so exciting, right? But this is one of those weird cases where the sine of that angle right here, um, well, it looks like acute. But if I did it over here, that same angle B is now 107. And so actually, because the sine of 73, the sine of 107 are exactly the same, I don't know which, and I'm using sines to solve a problem. It's called the law of sines. I don't know which triangle is the answer. So both triangles are the answer. We just don't know. So one possibility when you have when you're given bad word information, when you're given an angle and then two non-included sides, one possibility is that there is two solutions. Another case, if you make, let's just make this shorter here. So let's make A maybe equal to 3. Sometimes given information doesn't form a triangle. You see, no matter what angle C is, it doesn't even hit that triangle that at all. Like it doesn't hit there. So there's no way to form another triangle here. So if that's the case, um, then you have no solution. So it forms no triangle at all. So that's a possibility. So it could form two triangles. It could form one triangle. It also could, let's see what happens here. So I'm gonna make this 5, I'm not sure. Let's make it 6, in fact. Oh, wow. So you can see it definitely forms a triangle. But if I go over here, it doesn't actually form a second triangle. It doesn't hit anywhere in here where a obtuse angle would be. So if that side was 6, so depending on the given information, you might form just one triangle. You could sometimes form two triangles and sometimes form no triangles. So those are the three possibilities, and that's really what we're trying to get at here. Is how could we get those? So kind of wrote up a thing here. I think this is easier than then maybe like some books will have you memorize like some formulas and things, and this is not really about memorizing formulas, but it's kind of a sequence of 3 steps. If you make it through, you can figure out if there are 1, 2, or 0 triangles possible. And of course, this test is only if you're given the bad word information. If you're given side, side, and the non-included angle, you should do this test. So the first step is set up law of sines and solve. So the equation looks like this. So like sine of an angle equals some decimal. You want to just get to that point, not actually solving for the angle yet. If the sine is bigger than 1 or smaller than -1, it's not a triangle. So you can just stop. You're done with the test. You're done. If the sine is smaller than 1, like between -1 and 1, you will have at least one triangle. So then you want to take the supplement of the angle you just solved for and make a possible and see if you can make a possible triangle with that with the given information and that angle. So let's try this. This is very convoluted when you first see the steps, but let's just kind of do the steps. So first step is we're supposed to like set up the law of sines and start solving here. Okay, so let's set up the law of sines here. So we're going to say, let's label the given information here. So A is equal to 10. That's the side A. Angle A is 39. And side B is 14. So pretty quickly you can figure out that we're going to use the A there. So sine of 39 over 10 equals sine of B over 14. And so that was probably obvious to you that we're going to choose A. We don't know anything about C yet, so we're not going to use that ratio yet. We'll eventually have to do that, but not yet. So we're going to solve for angle B. So that's the first angle. We're going to set up and start solving, but stop right before we get to the solving here. Okay, so we're going to have 14 times sine of 39 equals 10 times sine of B. We're going to divide by 10, divide by 10. We get sine of angle B equals, I'm going to get my calculator out, and I'm going to make this just so I can see it, so I can type it in at the same time. Whoops. Okay, let me try one more time. Okay, so scratchpad, I am in radian mode, so I want to change it to degree mode. That's good to check. And so I'm going to okay, so we're going to type this in. So it's going to be, we're just evaluating right hand side. I'm not actually going to do the inverse sine yet. So 10 times, sorry, not 10. It's going to be 14 if I read it right. 14 times the sine of 39 over 10. I'm going to put a decimal because I want a decimal. Okay, so I get 0.8810. So this is not a number that's bigger than 1 or smaller than -1. So guess what? There's at least one triangle. There might be 2. So we got to do the test. So let's go ahead and find this angle here. So we're going to take the inverse sine using our calculator. So inverse sine of that decimal. I like just grabbing it. It's easier so that we get better representation there. So we get B, angle B equals 61, and that seems reasonable, 0.7691. Okay, so angle B is 61 point. I'm just doing this different numbers to differentiate here because I want you to realize that the 3 blue numbers there are all given information, and the angle is the one that we found, we solved for using the law of sines, but of course we don't know if that angle is obtuse or acute. So technically we don't know yet. So the step here, so if you read step 2, let's see, step 2 was, okay, so it is a triangle. We've got at least one triangle. Now we have to do step 3. This is kind of the toughest step here. So if the supplement of the angle you just solved for, so we just got that 61-degree angle, the supplement of that could make a possible triangle with a given angle, you must have draw a second possible triangle. Okay, so I'm going to go ahead and draw the second possible triangle. So when we do this, we typically, like I'm not worried about drawing it to scale. It actually, I think if I drew it to scale, it would be, I think it'd be like this, essentially. But it doesn't really matter. Just draw a second triangle. It's called A prime, B prime, and C prime. The given information is all the same. So, and the second triangle, that's 39, that's 14, that's 10 over here. So that given information is all the same. The thing that's different is this angle. So you want to take, I kind of draw a line, that's going to be the supplement. So you want to find the supplement of the 61-degree angle here. So 61, well, I've got it right there. So 180 minus that is, so that's 118.231. I guess it would be nice to get one more digit there. That's what I'd like you guys to get, 4 digits. 2309, 2309. Okay, 2309. Go back down there. Okay, 2309. Okay, so like we know this first one's a triangle. Like that's always good. If it passes the test, the sign was, between 0, 1 and -1. It's at least one triangle. I'm not worried about that triangle. We'll have to solve that triangle, by the way. We'll have to find its missing sides, its missing angles, everything. But we might have to solve this extra triangle as well. So for this one, we've got 118 and 39. Is that less than 180? It is. So guess what? We've got to solve all of all those. We've got to solve